Alright people, let's move on to Chapter 8, which is Energy and Atmosphere. You'll notice this is the credit category with the highest number of points or credits at 33. That's almost a third of the total. We've got 4 different prerequisites and a bunch of credits, including optimizing energy performance, which is 18. So half of the credits in this category are optimizing energy performance. I guess that makes some sense, doesn't it? So we're going to divide this into 5 different goals, and this video will be just about reducing energy demand. I have other videos for the others. So let's move on to talking about energy demand. So energy demand, reducing that could be as simple as like shutting the lights off, right? If you're just not using the energy, that's reducing it. And commercial buildings use about 20% or more. I've seen other data that showed it was more. So that's a good place to reduce energy use. Our infrastructure, the electrical grid, is having trouble keeping up for the demand for energy too. So if we just didn't need as much energy, and in this case we're talking about like peak energy demand, so the maximum amount we use keeps getting larger, then the grid has to be bigger and more substantial to handle that. So there's some ripple effects to energy demand. So energy and atmosphere is very similar to water efficiency in that there's a baseline case. And that in this case is ASHRAE, we usually call it ASHRAE 90.1. And could be 2010, there may be a newer one now, but the credits reference that one. Energy standard for buildings except low-rise residential buildings. These are some definitions here, what those standards are, but we don't need to get too far into that. So, some strategies. Start with a smaller building footprint, like in some of the other credits. Have mixed-use rooms or shared spaces, or have a very small, which is a tiny house. But another example, say in a school, do you need a separate cafeteria and gym, or separate cafeteria and theater, or separate gym and theater, or stuff like that? Things that you can maybe multi-use, particularly in a smaller school or something. Another strategy, passive design. Take advantage of the wind and sun, solar energy, daylighting, opening windows for ventilation, although in commercial buildings that adds some complication with mechanical systems. Things like light shelves, you can see in the winter, the sun is low, you get heat through the windows. When it's summer sun, it's going to hit that light shelf, still put light into the room if you use light colors, but you won't get the heat. So things like that. High performance envelope. The envelope is the walls, roof, floors, doors, and windows of a building. Have better insulation, higher performance windows and doors, that kind of thing. This is a project in Portland a few years ago. I don't know if it was real high performance or not, but it shows the kind of things that you want to do with the tape and air sealing of the insulation around the windows and in the joints. High performance envelope means better windows. So windows have U factors, solar heat gain coefficients, visible transmittance, and air leakage, and those are all summed up in a standard sticker that you'll see on any window. And we'll go through each one of these one at a time very briefly. The U factor is how well a product can keep heat from escaping from the inside, assuming that it's heat. It could be cool if you're going the other way. The lower the number, the better it is. Okay, so we're looking for low numbers in the range of like 0.2 to 1.2. Typical windows that we use here in the Northeast, a standard double pane might be like 0.22 or something like that. I've got some triple panes I did at my house in Hamden that are down at I think 0.18, so a little bit better. Solar heat gain coefficient. If you're trying to prevent heat from coming through a window, you have a lower number. That means that less heat is going to come through. But in our climate, you might want a higher number because we tend to be a mostly cooling climate. Visible transmittance. How well a product can let light through. High numbers, you get more natural light, you get better lighting. So in this case, we're looking for higher numbers. And finally, air leakage. All windows leak a certain amount, some worse than others. You think of the old houses we live in. There's a lot of air coming through the gaps around those old double panes. So you're looking for lower air leakage. Air leakage is bad. It takes heat out of the building at a pretty astonishing rate. I've seen numbers as high as like 30% of our heat is just air leakage from the standard building. Another strategy, commissioning. Commissioning we usually think of as at the end of a project when we're finishing it up, but it's really something that the commissioning agent should go through the whole design and construction process to make sure that things work correctly. They're essentially a third party double checking every performance aspect of the building. This is becoming a lot larger in LEED version 4. Starting from the energy goals at the beginning, what the owner wants for requirements, verification all the way through to make sure that this works. And this is a picture of inside of a building, I think in Portland someplace, maybe Mercy Hospital. Gives you an idea of the kind of things that commissioning agents look at. All these different mechanical systems, electrical, plumbing, steam, potentially steam, fire suppression, in addition to the envelope. So commissioning can be a very complicated piece of work. So this is a large apartment complex that we visited a few years ago in Marlborough, Massachusetts. And at the time, the commissioning agent had discovered that the windows were leaking, had done some testing, and that's why they're all numbered, because they're going through and they're kind of fighting about whose responsibility it was at the time. I don't know what the solution was, but eventually they fixed it. And then the last thing in this part is installing submeters. As we've talked about in previous categories, it's kind of your last option. Not as effective because all we're really doing is tracking building energy use. We really need to use that data to reduce our energy demand. So submetering, different systems, heating, cooling, whatever you got going in the building, still only 1 credit. That's it for part 1.